I've been hearing the word super cycle, for my entire career. And maybe this is the first one I've actually seen.
Now, all of a sudden, hardware's cool again.
Only thing we're hearing is that nobody has enough compute. You don't earn any money by training a model. You have to be able to use the model. So that is inference.
When the PC first came out, there were 50 companies, and now there's 3. And when the cell phone came out, there were 50 companies, now there's 3.
Hi, everyone. This is the TechSurge Deep Tech Podcast, presented by Celesta Capital. Each episode, we spotlight issues and voices at the intersection of emerging technologies, company building, and venture investment. I'm Michael Marks, founding managing partner at Celesta.
If you enjoy TechSurge, subscribe and leave us a review on your favorite podcast platform. Visit TechSurgePodcast.com to sign up for our newsletter and find our video episodes on YouTube. There's a word that gets thrown around in the chip industry every few years: supercycle. Most of the time, it's oversold. Every so often, it's real. Right now, the numbers are hard to argue with. The 4 biggest cloud companies are on track to spend around $600 billion this year, most of it on AI infrastructure. The semiconductor industry crossed $800 billion in revenue last year, and it's running toward $1.3 trillion. My guest is Stacy Rasgon, who is a well-known chip industry analyst for Bernstein. Unlike most analysts on Wall Street, he came up as an engineer, a PhD from MIT, who actually built chip manufacturing equipment before he ever wrote an analyst note. That shows up in how he reads the industry. Less speculation, more about the proven physics and capital flows today. We get into whether the AI cycle is really different, where the bottlenecks are, and who captures the profit when the dust settles. So the question is now that AI is driving such big numbers, big dollar volumes, and it's in the news all the time, which it never was before. Is something changed here, or is this just another version of this cycle, just a bigger version of it?
Yeah, I think that's the question, right? And it's funny, I've been hearing the word super cycle, for my entire career. And maybe this is the first one I've actually seen. And what's really interesting, there's a couple of different types of semiconductor cycles, right?
Right.
There are, supply cycles. You see these in memory a lot. Supply gets tight, prices go up, you add a bunch of capacity comes online. It turns out the demand you were building the supply for was not real, because customers, when they can't get the parts that they want, they tend to order even more, right?
Right.
And so supply comes online, demand falls, you gap out, and it causes problems. So that's a supply cycle, and they tend to last. Those are your stereotypical 4-year peak to trough kind of cycles. There are inventory cycles. Semiconductors are the back of the supply chain, and small fluctuations in end demand can kind of propagate backwards through the supply chain and have correspondingly larger impacts. And if demand falls off tactically, the customers may buy fewer semis and bleed off their own balance sheets. And in that environment, semis undership demand, and then you can go the other way when they start to replenish and they overship demand. And they tend to show up as resets one way or the other, and they tend to be a few quarters, right? You can get product cycles. I'll make it up. I'm a mobile semiconductor vendor making chips for smartphones, and did I win or lose the socket in the next iPhone? And that can drive lots of upside revenue or downside. So those kinds of cycles. This is like a demand cycle, it seems to be, right? And
there does seem to be, yeah.
Right. And I've never seen, we get those sometimes, I've never seen one on this scale before. The magnitude and rapidity, the speed at which this is actually ripped is something that I think is somewhat unprecedented. And it's really interesting because everybody sort of focuses on the AI semiconductors as and that's what's at the root of all the demand. Everybody wants to compute, but it's starting to drag everything along with it. So frankly, you can look, almost anything in semiconductors right now is working from a stock and from an earnings standpoint. And you've had this interesting move from category to category to category as one at a time. These things have gone into constraint mode. All of a sudden, we've utilized all of the available supply for various different things as the demand for accelerators and GPUs has gone up. So, it went from accelerators to memory, to semi-cap tools, to networking and optical to power semis and now even CPUs, right? Everything is getting dragged along by this insatiable demand for AI compute. And this is something I certainly have not seen anything on this scale in my career. And so then, naturally the question is, is it different this time? Is there ever going to be a peak? Are we going to roll over? Like, I don't know. All I can say right now is only thing we're hearing is that nobody has enough compute.
Well, so why don't we just
all the way long?
Yeah, look, I mean, I hear you about that, and obviously this is a huge thing. Why don't we drill down on one aspect of it, because it's a complicated subject. Let's just talk about memory, because memory was the classic cyclical semiconductor.
Yeah.
In fact, it's so funny. The guys would take turns on who was going to screw the other. So when there was not enough memory, the memory guys were charging up, and when there was too much memory, the other guys were driving the customers driving the prices down. Now, clearly, the memory guys are in huge demand. They're sold out for a long time. So is it possible for this to go on for years? Or, I mean, one of the issues here is there's no new entrants. And so you've only got what you got in terms of capacity. So can this go on for years and years?
Let's talk about memory. It's really interesting because this is probably the strongest memory cycle in history right now.
Right.
People forget 18 months ago, we were in the midst of the worst memory cycle probably since the tech bubble. Right. And by the way, you mentioned there's fewer entrants. You go back, 20 or 30 years, there were like 30 different memory guys.
Right.
There's like, depending on the space, there's, 3 to 6 now, depending on the type of memory.
Right.
And you can go back to that nasty cycle that we're coming out of. Like, I mean, it wasn't fun. Like they were losing money, but they were fine. You go back to the tech bubble days. I mean, we had bankruptcies in those times. So we don't have those before. The memory industry is better from that standpoint. And now clearly, we're seeing prices, double every quarter, and and demand is through the roof. And again, it really is being driven by AI. And there's a few reasons for it. And so I think it's important to separate the two primary types of memory, DRAM and NAND. They have a little bit different dynamics. Those are the two biggest pieces. DRAM is kind of like what most people use for like the little memory sticks that go into their PC, and it runs, the system as you're working. And then NAND is like what's in your smartphone that stores your photos, say. And within DRAM, there's some really interesting dynamics. So these AI chips use a lot of DRAM. They use a special type of DRAM. It's called HBM, or high bandwidth memory.
High bandwidth. Yep.
Yeah. So what that is, it's a bunch of DRAM chips that are all stacked up on top of each other and then packaged together. And then each AI chip uses a whole bunch of these packages of memory on it, and a lot of it. If you were to think about the wafer or silicon area in an AI chip, it's probably 85% plus HBM, I mean, if you were to add up all of the chip area itself. So it uses a lot of memory. And so not only is demand super strong, but there's another issue. They call it a trade ratio. What that means is to make, say, a gigabyte of high bandwidth memory, because of all the stacking and everything, you lose, you have lower yields basically. Like when you stack it, you don't get good chips out of everything you do. So the yields are worse. There's more logic dies that go into it as well, and you need to leave space on the dies to put the connectors so you can stack the chips together. So because of that, you need something like 4 times as much silicon area to make a gigabyte of high bandwidth memory as you do to make, say, a gigabyte of standard DRAM. And so you're in a scenario where we could, in theory, be adding a bunch of like wafer capacity to make DRAM, but not actually adding that many bits because of this.
Oh, that's interesting. Okay.
Yeah, and so for DRAM, as long as AI demand is growing, this can probably carry on. And clearly, if AI demand rolls over, then that would be a problem. But we're all screwed anyways if that happens. Right? So I don't worry too much about that scenario at this point. And there's no signs of it yet.
The question is, you've been looking at this for a long time now, and so do you see innovation, easing the pressure here over time, or is the demand just so overwhelming that even that can't make a difference?
I mean, innovation happens always. And it's really funny. There's been an overarching dynamic in semiconductors over the last 6 decades. It's called Moore's Law, which I'm sure many of your viewers have heard. But the idea of Moore's Law was every 2 years you were fitting like twice as many transistors in a given area of silicon. And the cost of that area of silicon didn't really go up. So you were effectively every 2 years making twice as many transistors for the same price, or getting twice as much, or getting the same number of transistors for half the cost, right? You also got performance improvements. The transistors got better performance and they used less power. So it was a wonderful thing. Moore's law started breaking down, over 10 years ago. But it didn't mean that you couldn't continue this technology. What it really meant is the cost leg of that three-legged stool was going out the window. So we can still get performance and power improvements, but now you have to pay for it. Like the cost per transistor is now going up instead of down, which is a new thing. And people were very worried that that would be the end of the industry. And it really wasn't. It opened up a renaissance in the industry, because what it actually meant was, now if you want these improvements, Mr. Customer, you have to pay for them. Whereas historically, the industry just gave it away for free. And I remember Henry Samueli, who's the CTO at Broadcom, and he was the co-founder at Classic Broadcom before Avago bought them. And Classic Broadcom did an analyst day. This is probably in 2012. And they were talking about this, right? And they were showing, TSMC cost per transistors. I think they bottomed at like the 28 nanometer node, which is a long time ago. But his point was, this is not a bad thing. The industry is about to become a rational industry for the first time in like 40 years. When Moore's law ended, innovation did not stop. We just had to go into other things. And there was actually an economic like cushion, I think, that actually helped to fuel this. And when you couldn't just like drive new functionality for free just by shrinking the transistor, you did other things. You mentioned a few, right? But they've gone to new transistor structures.
Right.
They've gone to, you talked about dicing the chips up, chiplet architectures.
Right.
Right. I can dice the functionality up into different types of silicon that are all sort of like collectively optimized for what they're doing. And then I can put those together in new and interesting ways. And that also lets you put much more compute on a single thing. Like, to make a single chip, you can't make it much bigger than about 830 millimeters squared. There's what's called a reticle limit. I can't physically make a single monolithic die bigger than that. But with some of these interesting packaging techniques, now I can put multiple dies together and build up a lot more. So you can put multiple compute dies. We're seeing that. Like NVIDIA's Blackwell GPUs is actually 2 GPUs stuck together. And then they got a bunch of these memory dies all stuck on there, like next to them on a what's called a silicon interposer. And you can build up much, much more silicon area and get more compute and do things. And again, it costs. Like these things are not cheap.
Sure.
But if you can give customers a reason to want to pay that cost, and clearly they do. I mean, NVIDIA's got 75% gross margins. So
there's so much to unpack here. If this begins to slow down in some way, what will be the sign of that?
Yeah. So, I mean, the things that we watch, I mean, clearly, the hyperscale CapEx numbers, they like all reported on top of each other on Wednesday. And
I know.
Still take CapEx up. But I mean, that's one. And to be fair, by the time you see that go down, it's probably too late. Right.
Yeah.
But that's a very public, like, sort of thing we'd watch. We're watching things, for example, like some of the revenue numbers at the labs. And this probably leads into a whole like discussion, which we'll probably get to on training these AI models versus using them. But for example, you can look at a company like an Anthropic, and they sort of like once in a while they'll talk about where their revenues are. And I mean, they've gone vertical, right? I think they recently said in April their annualized revenue run rate was like $30 billion, and in January it was like $14 billion, so more than doubled in a couple of months. It was like $9 billion in December. It was, I can't remember, it was $1 billion or like whatever it was a year ago. I mean, it's literally done this as people are now starting to use what they're delivering. People are looking, again, go back to the hyperscalers and looking at their cloud revenues and how much are those growing and are they accelerating? And then there's all of the noise and data points and things that come out of Asia. People look at, what are the wafer volumes that are getting ordered? What are the CoWoS? CoWoS is that packaging technology that's used to put the chips in the memory together. How much CoWoS capacity is getting reserved by all these customers, all those kinds of things. You're looking at the different players in the supply chain and, or how full are they? Are they sold out or are they not?
Right.
Like I said, right now, everything is looking like this. It's the general consensus is there's not enough compute, at least at this point.
As I'm mostly interested in the sort of long-term structural changes that are being created from all of this, as opposed to the short-term stock impacts and all that stuff, you just raised an issue on supply chain that I wanted to delve into a little bit, because one of the things that's different this time is how much vertical integration is going on at the hyperscalers.
Yeah.
I mean, that's something very interesting. They're designing their own chips, they're building their own data centers, they're setting up their own, financing structures, they're controlling cloud access and so on. What do you think? What do you think that impact is? I mean, that's unusual. The world's basically been de-vertically integrating, and now we're going the other direction.
Well, to be honest, like the hyperscalers have been doing chips for a while. So for example, Google has their own AI chips. They call it a TPU, stands for Tensor Processing Unit, and they work with Broadcom and others to build these. They've been building these for 14 years. Like they're on their like 8th generation and getting ready for their 9th, and like it's not new per se. The idea that they're working. Amazon does their own chip. It's called Trainium. I can't remember how many years. It's been 5 or 6 years. Amazon in particular on the CPU side they have a server CPU that's their own design. It's called Graviton. They've been doing it for, I don't know, probably 6, 7, 8 years, maybe longer.
Yep.
So the idea of at least the hyperscalers vertically integrating into semiconductors is not necessarily new. Again, the demand profile that they're building for is certainly much bigger than it used to be. But the idea that they need to vertically integrate into that is not new. Not even the hyperscalers take it up like an Apple. So Apple does a tremendous amount of their own silicon. They do their own. They migrated their entire PC platforms off of Intel, and what's called the x86 compute architecture to their own custom ARM. What's called ARMS, the company that does the licensing, ARM-based architecture. They're starting to do their own cell phone modems, radios that Qualcomm currently supplies, and that's going in-house at Apple. They do some of their own connectivity, like Bluetooth and Wi-Fi and other things, and so Apple, for example, has a very strong internal silicon. They've been doing that for like well over a decade.
Okay, but let me separate those if I might, because Apple is a hardware company, whereas Meta and Microsoft and
they do a lot of data centers. Even on the data center side, like for Google, for example, like they're not really necessarily like buying their servers from Dell. Like they have a white box model, so they sort of spec out exactly what they want, and then they go. To like these guys, ODMs in Taiwan, and they'll build it to their specs, and they'll use like off the shelf silicon, from Broadcom or whoever. But I mean, they've got pretty strong hardware chops too, and I don't think that's
fair enough. Fair enough. Well, do you think that this vertical integration is being done to avoid bottlenecks, or is it being done to create more margin, or is it more protection against competition?
I think it's all of the above. So I mean, it's bottlenecks because you don't want to be, some of it maybe. Although even there, like they're not actually physically building the stuff, right? So you can still get bottlenecks. Some of it is performance and spec. Like because think about it. These hyperscalers have very large, stable, like internally developed workloads. So they know exactly what they want, and they can optimize for it. And so if it's your own sort of custom designs, you can optimize everything very, very closely and get better performance on that basis. That's good. There's probably an aspect of competitive threats. I mean, you don't necessarily want to be fully dependent on a single sole supplier. And so, like on the AI side, I mean, these guys buy a lot of stuff from an NVIDIA, but I mean, they do their own work as well. Right. Sure.
Do you see other bottlenecks developing in ways that we don't hear about very much? For example, one of our companies was Credo, which went public a few years ago at 11, and now it's at 175. They're buying another one of our companies, Dust Photonics. These are things, most people who are following stock markets, if you will, don't know about optical connectors, or, we have a company that's making silicon timing chips. And, there's all these little things that are happening that are interesting from an innovation standpoint, but they could also cause bottlenecks because these are smaller companies.
Sure. Yeah. I mean, they're all sold out, right? Yeah. So, and again, the bottlenecks have been interesting because people have been playing the bottlenecks. I know you want to talk too much about stock prices, but just in general, you can sort of look at like the stock prices of, say, like the compute names, and they've kind of stagnated for a bit. And yet you can look at like the memory and the semi-cap and the optical, like these bottlenecks, which have all ripped. And so people have been really playing the constraints, right? It's funny too, because like in some sense, one of them is wrong, right? They're not, those two trends are not really consistent with each other. So it probably does have to normalize at some point, one way or the other. But there's been a lot of bottlenecks, and I found it really interesting how you sort of bounced from one to the next. And I feel like it's almost as the AI demand has taken off, all of these guys have, whatever it is, X amount of capacity that they can bring into the market. And we've just been hitting those levels one at a time for like the different areas at different points in it. So like I said, it was memory and it was optical and it was semi-cap and it was power semis and CPUs now. And I think people are starting to look deeper into the supply chain, substrates and,
right.
like a lot of the companies are now complaining about like their own input costs going up because like even the raw materials are now starting to get tight.
Their own, what costs going up?
The raw materials, like
okay.
substrates and T-glass and like all that. Intel like talked about some of this. Intel reported earnings like last week, and one of the things they talked about was like when their input costs are going. So they're trying to raise price on some of the stuff. By the way, as an aside, the industry collectively has had pretty good pricing power. So during COVID, we had a massively inflationary environment, right? And all of these guys had their input costs going up. Broadly, the industry was able to pass those costs along, and they did it at their margin structure. So it's like, I've got a 60% gross margin and my cost went up $100 and I'm passing along 160. And they all broadly did it. And I didn't have a single company of mine complain about margin compression because of input costs going up. And interestingly enough, if you look at the industry, you compare 2019, which is the first year pre-COVID, versus say 2024 when everything finally normalized, right? Units were roughly, for the total industry collectively, were roughly flat, 2019 to 2024. ASPs collectively 50% higher.
Well,
really amazing.
We get into this a little bit, might as well do it now because you're really talking about oligopoly pricing. So we do have a situation here where there aren't very many suppliers. And when you have a lot of demand and not very many suppliers, you can raise prices regardless of the environment.
Not always, but I mean, pricing
not always.
Is stronger, and it's really coming to memory. So I mean, you can look. I think in February, industry revenues it was something crazy. It was up something like 80% year over year,
right.
And it was almost all memory pricing. To be fair, right? Memory pricing is I mean, it's gone ballistic, and it's sort of interesting. For a long time, people coming out of COVID, were talking about a semiconductor industry that could be, $1 trillion in 2030. Right. We did roughly a little under $800 billion last year. This year, we are already on a run rate to exceed $1 trillion. I think we did over $100 billion in February. Now, to be fair, a lot of that is memory pricing and NVIDIA gross profit dollars.
Right. Fair enough.
But even so, maybe we're doing $2 trillion in 2030 now. Like, I don't know.
So do you see any other new entrants into memory? For example, any of the hyperscalers? Because
the Chinese are probably the biggest entrants. See, they're already there. There's two primary Chinese players. There's CXMT, who does DRAM, and YMTC, who does NAND, flash. And they're a little constrained. They've been on the U.S. has sort of put them on sort of some regulatory blacklists. And so it's been harder for them to do business on a global basis. And like for example, the semi-cap guys, at least the U.S. players who sell the semiconductor manufacturing equipment, have not been allowed to sell tools to them.
Right.
They're capable though. Especially YMTC on the NAND side is pretty capable.
So do you think
other memory entrants? I don't know. Like it's tough. I don't know.
The hyperscaler giants are spending somewhere north of $600 billion this year on this build-out. Total AI revenue, everyone's combined, is still well short of that. Spending on AI infrastructure reached about 4.4% of U.S. GDP last year, close to the peak of the dot-com bubble. Optimists think that demand is racing to fill the gap, and they can point to real, fast-growing revenue. Skeptics think a lot of this capacity is being built on faith. The thing that will decide this isn't the models. It will be inference. People actually using the models every day and paying for it. These cycles are interesting to me. Yeah. One of the things that's happening, we've got this whole move to inference, which, I'm sure you know plenty about, talk about all the time. Let's talk about that for a little bit, because one of the things that's happening is that's a bit of reordering the deck chairs, if you will, because now there's sort of a new game in town. I'm going to come back to the specific players, but just any comments about what's happening in the industry because inference is taking over.
You bet. So a lot of the spending has been on training, and basically, I need to determine the potentially trillions of parameters that need to be set in these big models for them to be able to do stuff. Right. very compute intensive, requires a lot of money, and they buy a lot of GPUs and other stuff to do this.
Right.
I usually get the question a lot. Well, when do you think the spending will ever like pivot from being training dominated to inference dominated? And my response has always been, well, it better, because if it doesn't, we have a problem. Because training is important. You need to do it, but like you don't earn any money by training a model. Like
right.
NVIDIA earns money by you training a model, but you buying the chips doesn't. You have to be able to use the model. So that is inference.
Good
right?
point. Yeah.
For that. And again, I think we're starting to see it. So it's beyond just the chatbot stuff or you're making slot videos or whatever. People are starting to get very excited about what's called agentic inference. So
right.
I've actually got the model that can actually go out and really perform real world tasks for me. And again, coding is probably the application where we're seeing the biggest piece of this now. And again, I mentioned Anthropic's revenues. But clearly, most of that is agentic coding, where you've got these agents that are actually helping you or doing code for you, and
right.
Clearly they've got something that people are willing to pay for. Right.
I do hear that people are getting a bit shocked when they get their bills, though.
Yeah, it's funny too, because a lot of companies, we're laying off employees like to spend on AI, and it's, well, wait a minute, we're spending more on tokens than we were on the employees that those tokens are supposed to be replacing. Right? So yeah,
exactly.
Now I guess if those tokens are more productive, maybe it's okay. Right? But yes, I think we are starting to see it. It's still early. We're clearly starting to see it, and frankly, it's some of the things that you're seeing constrained, like for example, the CPUs. Those are getting constrained in part because like a lot of this inference stuff, it uses a ton of GPUs, but it uses a ton of other stuff too. Right. And the fact that we are seeing those kinds of constraints now is another real indicator that we are starting to see a pivot toward inference. Yeah. And again, we can still, I think, have justifiable debates on the return and what do the economics look like. I think the industry is still working through that. And it's sort of hard to say because we're in a ramp phase. In a ramp phase, like you're always going to have high CapEx. Right. And It looks like it's burning cash and everything. So you have to sort of normalize out what is it going to look like once the investment's made and how much profit can you derive. But the more the revenues are growing, I find that very encouraging on the inference front.
So you have these new
we're in the midst of the pivot now, I think.
Yeah. Well, one of the things I want to talk about is one of the implications of that is you have these, inference focused startups like Groq and Cerebras, Sambanova, Tenstorrent. You got this new category of companies that are not in the public knowledge domain as well as NVIDIA and Broadcom, these others. Yeah. How do you see that playing? I see them all get bought up by the same players. I mean,
it's interesting because, so for example, like NVIDIA just bought Groq. Why did they do that? And they just had NVIDIA had their GTC event, the GPU Technology Conference. They do it every March in the Bay Area. Right. And Jensen they just bought Groq, so they were talking about it. And I finally understand like what was going on. And one of the takeaways I took from there was I kind of had this just sort of dumb, simple view that like a token is a token is a token. And by the way, when I say token, a token is sort of like the chunk of data or information that these models are based on, either that they're taking in or they're spitting out. And we can go think about it as like a word or like a piece of information like generated or used by the model. Anyways.
Yep.
And when you're buying capacity, in many cases you're paying like by per million tokens or whatever, right? So I'd always just thought about, okay, like a token is a token is a token. I'm renting out X number of tokens. And what Jensen said, which kind of makes a lot of stupidly makes a lot of sense when you think about it, is they're not all the same. And some tokens can be monetized at a far higher rate than others. And in particular, the tokens that require really low latency, like really fast responses. Jensen's view is that those, if you're, say, a neo cloud and you're renting this capacity, that you can rent out that kind of capacity at much better economics. That's why he bought Groq, and that's what Groq was for. And some of these inference-focused startups and others you mentioned, that's kind of the idea. They're focused. So it's not for everything, but for that certain subset of tasks. And again, I'm grossly simplifying here, but that certain subset of tasks that require like really fast responses, really low latency. That can work really well. That's not a thing that like a GPU is necessarily like the best suited for. So that's why he bought Groq. And
yeah, that's what I understand. Aren't the rest of these guys?
Hey, it's bad. Jensen's admitting that GPUs aren't the best for everything. But to be fair, Jensen's also big enough and not full of himself enough to he can admit when he needs to fill a hole. right?
Well, it seems to me like all these guys are going to, that when I say all these guys, you've got a very small group of players. And now you have this pivot to inference, which we're talking about.
Yeah.
And so NVIDIA bought Groq, but these other companies, it seem like they're all going to get bought up as well.
Maybe I'm not going to speculate on potential M&A here.
Yeah, of course.
But I mean, they've got assets that I think at least the Groq acquisition that NVIDIA did, that it validates. Right.
Well, one of the things that I think about, having been around for a long time, just like you, is, when the PC first came out, there were 50 companies and now there's 3. And when the cell phone came out, there were 50 companies, now there's 3. And we're going through a lot of that right now in the AI revolution. That's why I think there's what I refer to as vertical integration. So I'm not trying to speculate on any particular company, just looking at how the industry is changing from a structure standpoint.
Yeah.
Why don't we talk for
all of them, right?
One of the things that doesn't get talked about very much, and I know you're a follower, is the semiconductor equipment side.
Yes.
If you look at their stocks, they've all gone up, but at nowhere near the rate of these other players. So what's going on there?
They've gone up a lot. I mean, just to pick on one, Lam, who make etch and deposition. I mean, that stock at the beginning of last year was $70. And I can't remember what it is now, 280 or something. It's tripled or quadrupled.
Applied Materials, I think, has doubled this year. ASML has maybe doubled.
They haven't gone up 10x like the memories. And you got to remember, like I said, I'm going to make up the numbers. I don't know what it is, but I mean, Micron, SanDisk or something. They're guiding to a higher EPS, than the stock price was, 18 months ago or whatever.
Right.
So,
right.
You're not seeing those kinds of revisions.
Right. But what are the impacts on equipment? Because it's a longer cycle and tell us about that.
I mean, like, to be fair, like in memory, it tends to be price driven. So I mean, if I'll make up the numbers, but if the ASPs are going up 10x, the stock semi-cap ASPs are not going up 10x, right? And frankly, semi-cap's interesting because like this is going to probably be a pretty strong year for what's called people sometimes they call this WFE, wafer fabrication equipment. So this should be a pretty strong year for WFE. But as strong as it is, it's a constrained year because if I'm selling semiconductor manufacturing equipment, I need somewhere to put it. I need what's called a fab. The factories are called fabs. I need a clean room, or sometimes they call it a shell. I need a clean room, or a factory to put the equipment in. They don't have the factory, so I have to build the factories first. And so as strong as this year, that is a constrained year. So they're building the clean rooms. Those will start to come online and be available to accept shipments like next year. So that's sort of a constraint. And frankly, someone will probably talk about AI bubbles or not. But I don't think this is a bubble. We're not anywhere near crazy enough to be bubble yet. We can talk about what we might need to see. But in some sense, this is sort of a mitigating factor. Like there's in some sense a hard physical limit on how much the industry can expand. I bet if like the clean rooms were unlimited, we'd be selling a ton more equipment this year. And whether or not it would actually be shipping too much, I don't know, right? But we'd be shipping a ton more. So there's this sort of natural constraint on how quickly things can ramp because we just don't have the semiconductor capacity to do it. And so it will take time to bring that online.
So following up with that, I would surmise that what do you think is there'll be a long upcycle for the semiconductor equipment guys, just because they're going to be filling a backlog of demand for many, many years.
Probably, yeah. Unless AI demand rolls over again, in which case we're screwed anyways. So who cares, right? I mean, that's.
Are there any new entrants worth watching in the semiconductor space, equipment space?
There are some. I mean, there are. There's the big five. There's this ASML, Applied Materials, Lam Research, Tokyo Electron, and KLAC.
Sure. Yep.
And those five collectively are all roughly 70% plus of total WFE spend. There's a long tail of more niche or specialized guys. You got like Onto and Nova and I don't know. There's smaller like subsystem guys, MKS and Ichor, and they make like subsystems that go on the tools. I think where people look for others is the Chinese. And there are some Chinese companies that make the stuff who are actually pretty good at what they do. They're not as good as the US guys. They can't do everything, but they've been taking some share in part because of the regulatory environment. The US players have had limits placed on them in terms of what they are allowed to sell into China. Because of that, the Chinese players, I mean, they're probably taking more share than they would ordinarily deserve to take because they have no choice.
That's interesting.
It's been manageable. It's been fine. Demand overall, even for the U.S. guys, even in China, has gone up rather than down over the last several years.
Yeah, well, it's funny because of all the geopolitical stuff, and you forget that there's a real source of, some of these bottlenecks we talked about earlier can be alleviated by the Chinese. That's a good point.
Over time, and look, that's a whole other debate. Is it a good idea to limit what you're selling into China or not? Because then you encourage them to be creative in all senses of that word. We're seeing that on the AI chip side right now because they're not allowed to sell AI chips into China. And so China has local players that are making AI chips that are not nearly as good, but they've got a lot of power at least. So they can brute force these big clusters. They don't care about energy efficiency. And, in 10 years, what does it look like? I don't know.
So since you know so much, I'd like to ask just a couple of things from a company standpoint. I think there's nothing left to be said about NVIDIA, but it would be interesting for our listeners if you could talk about how Broadcom has taken advantage of this, because Broadcom's not as well known as NVIDIA and Intel in terms of their chips, but they do some things incredibly well. Could you talk about that for a minute?
They do things amazingly well. Yeah, I like Broadcom. It's got great leadership, and their execution is top notch. And so what does Broadcom do? So before all this started, Broadcom was sort of like an agglomeration of lots of things, but the company had grown through acquisitions over the last 10 or 15 years. And actually, the reason it's called Broadcom, the ticker is AVGO, which was
Avago.
It was called Avago, and Avago actually bought what I would call today classic Broadcom, and kept the ticker but took the name.
Right.
Anyway, so classic Broadcom did wireless stuff. They did like RF filters and the Bluetooth and the Wi-Fi stuff that's in the iPhone.
Yep.
They did things like broadband set-top boxes and cable modems and things like that. They did storage chips and things, and then their most important business was networking. And they'd done custom networking chips. And then when Avago bought classic Broadcom, they got what they call merchant silicon based switching and routing. So that was classic Broadcom.
Right.
Then they started getting into software, and they bought CA Technologies.
Yep.
They bought which did and does mainframe software. They did and they bought Symantec's secure enterprise security business, and then they more recently bought VMware that does virtualization. And so before the big AI run started, they were probably roughly 60% semis, 40% software, really high margins. And Hock Tan, the CEO, would sort of always talk about semis are a mature industry, and we're probably growing mid-single digits. But we generate a lot of cash, and the multiple was reasonably low. I always thought the multiple was too low, but it was pretty low. Now, as part of this, though, they'd always done custom chips, custom networking chips, and custom what he calls compute offload. Today, the AI stuff, but it was compute offload, compute accelerators. And I mentioned earlier, Google's been doing this for like 14 plus years, working with Broadcom.
Right.
And it was not a big business. I can't even remember. It was $1 billion a year, whatever it was, right? Fine. And then the AI thing started, right? So NVIDIA, ChatGPT showed up in November of 22, and NVIDIA sort of had the print heard around the world in May of 23. That was when their big revenue ramp started. And then Google and the others started to get more excited. And I'll be honest, I remember my own view. Hock started and Broadcom started talking about it around kind of like second half of 2023. And it was funny. They were talking about it, but you could sort of tell he wasn't sure if he believed it or not, I think, right? But they sort of said, we're starting to see this, and it's networking and it's, and by the way, we even talk about network. Networking is as important as the compute in all this. But we're seeing upside networking and compute, and then it just exploded, right? And I mean, their last, just to give you some context, their last earnings call, they said next year, they think that they can do $100 billion in AI revenues next year. And frankly, they'll probably do more than that, right? Just to give you some scale of some idea of where the revenue scale was. I mean, this is a company that used to do, tens of billions of dollars in total revenue. Right. They'll do 100 billion plus in just AI revenue next year. And it's really taken off because within the AI space, you've clearly had NVIDIA who's been dominant, but there are large players who have, in many cases, were already doing their own chips, who, number one, want to customize their chips for their own specific AI workloads to get higher efficiency and higher what's called total cost of ownership, TCO. And then there's always the competitive thing, like NVIDIA's, they've got 75% gross margins and they charge a lot of money. And at a minimum, you'd love to have something in your pocket when you're sitting across the table from Jensen, like negotiating on next year's contract, right? So,
yeah.
And I like both the GPU and the ASIC. What they call the ASIC stands for application specific integrated circuit. Custom chip is what it means.
Right.
I'm bullish on the GPU and the ASIC side. I figure ASICs probably will take share. You're coming from a lower base, but they're not universally used. Custom chips tend to be used for what I would call large, stable, internally developed workloads. So large because it's expensive. So you need to have a lot of workload volume to amortize that over in order to make it cost effective. Stable because like that's the trade-off. Like I'm willing to stipulate that the cost of ownership for an ASIC should be lower for the workloads that it is designed for, because otherwise why are you bothering? But it's not like it's magic. Like it's a trade-off. There's no free lunch. Like if your model structures change, if your workload change, you need to design a new chip. Whereas the GPU is programmable, so you gain flexibility, right? But if your workloads are stable and you can design the chip specifically for that, you should be able to get better economics. And then internally develop, because like you want to design it for your own specific needs. So that's probably not 80% of the market. I mean, today ASICs are probably, if you were to add it up, it's probably mid-teens of the revenue shipments. It's probably higher on a unit basis. Probably mid-teens on a revenue basis. Could that number go? Could it be, I don't know, 25% or 30% of a much bigger pie? Yeah, maybe.
So getting to be a pretty big number.
Yeah,
that's also reasonable. Go ahead.
But again, and it's a big controversy, by the way, the whole TPU versus GPU and who's winning or losing. And my view has been it's the wrong question. The right question, and I'll keep coming back to it. The right question is the opportunity that's still in front of us still big, or is it not? Because if it's big, I think they both thrive. If it's not, they're both screwed.
Well, that's a perfectly good segue to the other company I wanted to just touch on briefly, which is Intel.
Yes.
And and in full disclosure, I think that I started this firm with Lip-Bu Tan. We started it together, and I'm a big fan of his. And I know I've seen your CNBC stuff. Maybe it's ahead of itself in price and stuff. But let's talk about let's talk about the Foundry part of the business, because I mean, there's a lot of argument. Foundry doesn't belong, blah, blah, blah. But, there's real issues in foundry capacity here in the world, and geopolitics and TSMC and being under the watchdog, all that kind of stuff. So how do you feel about the foundry business at Intel?
So look, I think, so let me step back. So this is sort of Pat Gelsinger's baby, right? And I don't think the strategy was wrong. I think foundry is important, and both from a national security issue as well as just we need it. I think Pat's execution on it was not good. He was, look, I don't know who comes into a turnaround story and acts like Pollyanna, which he did, right? He hired 21,000 people and then he had to fire them all. And Lip was doing a better thing, which is you come in and you underpromise instead of overpromise, and you got the cost structure in place. And it's like, look, I'm so happy to be back, but like, you're going to have to be patient. Like it's going to be a slog, right? That was the right response. Versus like Pat coming in and saying everything is perfect forever, right? Yeah. So and by the way, I like Lip-Bu. I've known Lip-Bu a long time. I like Lip-Bu a lot. He's doing the right thing. He's not a magician, but he's very good. He's probably what they need. He's technical. He knows how to run a foundry, right? He basically founded SMIC, and he was on the board there for 20 years and whatever. And he's involved with tons of startups who are all TSMC customers, so he knows what customers want. And he knows everybody in the industry, and he's a relationship builder, so he can pick up the phone, he can call CC, he can call Jensen, like whatever, right? Is what they need. It's still a slog, though, and to his credit, he hasn't denied that, right?
No, he certainly hasn't.
No,
but there aren't very many foundries in the world. It's another one of these oligopolies, and so there seems to be a need
and so I think with Intel, there's no question that we need the foundry. The question is, can they deliver on it or not? I think that's still TBD. Right. And
so what do you think about?
We'll have to see.
What do you think about their shareholder base? Now they have the U.S. government as a shareholder. They got NVIDIA as a shareholder. They got SoftBank as. Is this good for them as a public company?
Does it clearly been good for the stock? I will say.
But this isn't a show about stock performance. Near-term stock performance.
It's funny though. Look, I'll be honest. I made my career being negative on Intel, and it was the gift that keeps on giving for like 15 years. And clearly, like the market has another opinion now, and that's fine. Like I said, we need them, and at a minimum, I would say, because of these investments, you asked, is it good or bad? Like their balance sheet's in a much better place.
Yeah,
that was a real question for a long time. Like, are they going to be around or not? Right. So I don't think that's a concern anymore, and that is valuable. Right. I think the government stake, and look, I don't like it, but at the same time, did it give other folks a vote of confidence? Like maybe, right? I mean, look, you got Trump like tweeting out like every other day, like how great his investment in Intel is. Like that helps, right? It gives other people confidence. But I think the fact that I mean, look, if they really are going to pursue this strategy, they need a lot of money.
Yeah.
And it was really questionable, like for a long time,
right,
whether or not they were going to be viable. And there was talk for a while that they were going to have to get carved up for parts, right? I think that's off the table now. And I think from that standpoint, the investments from the government, the others are valuable and clearly are positive. I mean, yes.
Well, you touch on something that's near and dear to my heart, which is balance sheets, which nobody talks about. And you're exactly right with Intel. They were, in a world of hurt from the amount of debt that they had coming due, and people weren't talking about that. But you're right. One thing about having these investors is that now they have a much stronger balance sheet, and that takes some risk off the table. So I think we can agree. Everybody more or less is pulling for Intel to survive here and to be a strong company.
You don't want to see them fail. I mean, like, and to their credit, I mean, let's talk about the good things, right? So, their new products, their 18A product, Panther Lake.
Yeah,
looks like a great product. I wish they could make more of them. I mean, they talked about like the yields are better than they thought, but I mean, clearly, you look at the margins, the yields are still not good.
Right.
But the products they're making with them are good, right? So the process itself, if they can get it to yield, is good, right? So that's a positive. And frankly, on the server side, I mean, their products and servers are not good. And Lip-Bu's admitted this, and he said, we won't really be competitive till we launch Coral Lake, Coral Rapids, which is 2028 or whatever. But the environment is good, right? And look, I mean, you take lucky over good any day, like it's fine, right? I mean, take it when it happens. The server CPU demand is really strong right now. It is so strong that last quarter they had some margin upside because they were selling like previously written off like garbage that was like lying around in the corner of the warehouse someplace. Demand is so that they've written off to zero, right? The demand is so strong, the customers are like, we don't care, we'll take it. Please sell it to us. Right? So that may help. Whether it's luck or not, it doesn't matter, right? If the server demand continues like that may help a lot.
Yeah, I agree.
Right? Yeah.
Well, this is fascinating. Before we get wrapped up here, or as we're wrapping up, I want to talk a little bit about the future. A couple of different questions I'd like to ask you. One is, so everybody is all up and to the right, blah, blah, blah. What are people missing? Anything? Are there risks here that people aren't paying attention to?
Yeah, I mean, look, so I think the question of returns are still a valid debate because you can make the simplistic argument, well, of course demand is off the chart, like it's free, right? So how are they going to monetize this? And again, I am very encouraged by seeing some of these revenue footprints go up a lot. But I mean, I think that's still an open debate. How does this stuff ultimately get monetized? I think there's a debate, how many foundational model companies are actually going to be around. We've got a bunch of them, and do we need all of them or not? And
we're not going to need all of them. This is an oligopoly business.
And if some of them go away, do the other ones that are left absorb the capacity or not? Like, I think those are debates. Where does the power come from? So that's something. Jensen said at one point we were going to be spending $3 or $4 trillion a year on infrastructure. And it sounded crazy at the time, although I'd say that we're probably getting close to $1 trillion now. So $3 trillion off of $1 trillion maybe it's not as much of a stretch, right? But I think that's a real question. Like if you were to ask me, like if there was by 2030, if there was actual like real demand to build out $3 trillion or $4 trillion of capacity a year, do we even have the power in place to do it? Like maybe not. Like certainly not. The electrical grid probably can't handle that. It was funny, I did a piece of work. Oh God, it was probably 1.5 years, 2 years ago even. Numbers even bigger now. But the idea was I was working with one of my colleagues who covers like the electrical equipment names. And it was like, okay, here's the forecast for NVIDIA and how much would the electrical grid have to grow to support that? And you know how this is, you build a model and you make a bunch of assumptions, like whatever, right? So, but it spits out an answer. I can't remember. I'm going to make it up. But it was something like, the U.S. electrical capacity has to grow at like 5% a year for the next decade or something like that. So I looked at that and I was like, yeah, okay, that sounds right. And my colleague looked at me like I had two heads. I was like, you've got to be out of your mind. Like there's no way. So in his world, like 5% a year is like unachievable, right? So what does that mean? So there's a lot more things like local, like on-site power generation that has to get done. I mean, they're even, they're talking about turning back Three Mile Island back on at some point, right? I mean,
well, we all know that huge demand creates innovation, and
yes.
There's going to be innovation in the energy side, just like there is in all these other things.
Yeah.
I
never discount human ingenuity. Like engineers are smart. If there's a business case and a reason to get something, then they'll figure out a way, probably. Right.
I think that's right. Any kind of a last orientation, we're a venture firm over here. Any holes in the market that you see that need more entrepreneurs to get in and innovate in?
I don't know. I mean, there's always room. Yeah, I'd have to. I'm not sure. Probably.
I think most of them personally are around these areas that reducing energy.
Like what I am just happy about though. I am happy to see more and more semiconductor startups because it was funny. Like 10 years ago, I sat down. I started to do a piece of work on like VC in semiconductors, and I shelved it because like there wasn't any. Almost all of the VC work at that point, they were like corporate VC arm. You have like Intel Capital or Applied Capital. Right. That was where it was all being done. There was hardly any because it cost a lot of money to design a chip and a lot of time. And like it was much easier to build some sort of SaaS startup or something, right?
Exactly.
I'm really happy, regardless of what happens to all these startups. I'm actually really happy to see a lot of like startup innovation happening in silicon again. It's about time.
That's kind of the way we feel. We've been investing in this for years. So, all right, last question. So if we have you back on the show a year from now, and I really hope we do, and the world plays out roughly the way you expect, what's the industry look like? Who's won? Who's stumbled? What did you get right? What did we get wrong?
Bigger. Yeah, I mean, hopefully bigger.
Better be bigger.
Better be bigger. Yeah, I mean, better pressure going into place. And I mean, I'd love to really, I'm very curious to see like where the inference demand and the revenue is, and frankly, like more and more workloads. What kind of workloads are really getting adopted? And ideally, like not even so much by like engineers, but like just like you and me, are normal people actually starting to use this like in a bigger way, in ways that are increasing like value in their life. I would love to be able to see that in a year. So like we'll see. Okay, well, as I said, we'd love to have you back, and it's been great so much energy, Stacy. Just great to see. I have to say, so I've been doing this 18 years, and my view has always been like, it's the longest I've ever done anything. And it's like, I'll do it until it's not fun, and then I'll go find something else to do. I can always find something else to do. Every single day, like I love this industry. I do too. Well, thank you very much for joining us. It's really been great. Thank you, Stacy. You bet. My pleasure. Anytime. Okay. Bye. A few things to take away from this one. While everyone has been watching NVIDIA, the biggest stock moves came from the bottlenecks: memory, optical, the equipment makers. In a supply-constrained boom, the leverage sits wherever supply is tightest, and that bottleneck keeps moving. The second is that the constraints are shifting from the chips themselves to the physical world around them. The hardest problem in AI may no longer be making the silicon, it may be powering it. U.S. data centers used about 4% of the country's electricity a couple of years ago. By 2030, that could roughly double, and around 2 terawatts of new power is already stuck waiting in interconnection queues. And the last one is the question nobody can answer yet: whether the revenue catches up to the spending. Everything in this episode runs on the bet that it will. Thanks for tuning into the TechSurge podcast from Celestica Capital. If you enjoyed this episode, feel free to share it, subscribe, or leave a review on your favorite podcast platform. We'll be back every 2 weeks with more insights and discussions of all things deep tech.